You're in the middle of a long conversation with ChatGPT. You've given it context, explained your project, shared your preferences, and then 20 minutes in, it responds with something that completely ignores what you said at the beginning. It forgot, not because it's broken, because of something called the context window. Most people assume that AI models remember everything in a conversation. You said it heard it, it should know it. That's how human memory works, right? Here's what's actually happening. AI models don't have memory, they have attention. And attention has a hard limit. Once you cross that limit, the AI doesn't just slow down, it starts dropping information. Permanently. I'm going to explain exactly how this works, why it matters, and most importantly, how to use this knowledge to get dramatically better results from any AI model. By the end of this video, you'll understand why your long conversations break down, why the AI sometimes forgets the most important details, and what you can do to fix it. Let's start with the foundation. First, you need to understand how AI models actually read your messages. They don't count words, they count tokens. A token might be a full word, part of a word, a comma, or even a space. On average, one word equals about 1.3 tokens in English. But in other languages, or with technical content, that ratio can be much higher. Now here's the key concept. The context window is the total number of tokens the model can see at any given moment. Think of it as the AI's short-term memory. Everything inside that window is visible. Everything outside it is gone. And here's what most people don't realize. The context window includes everything. Your messages, the AI's responses, the system prompts running in the background, any files you uploaded, PDFs, code, spreadsheets, all of it counts against the same limit. So when you're in a long conversation and the AI suddenly seems confused, it's not malfunctioning. It's running out of space. The oldest parts of your conversation are being pushed out to make room for the newest parts. The AI isn't forgetting. It literally can't see that information anymore. But here's where it gets more interesting. Even when information is technically inside the context window, the AI might still miss it. And there's a scientific reason why. Researchers published a paper called Lost in the Middle that revealed something surprising about how AI models process long texts. They found that models are most accurate when information is at the very beginning or the very end of the context. But information in the middle, it gets lost. The pattern forms a U-shaped curve. High accuracy at the start, high accuracy at the end, significant drop in the middle. This happens because of how the self-attention mechanism works. The model assigns importance scores to different parts of the text. But with very long contexts, this calculation becomes complex, slow, and error-prone. The model essentially loses focus on the middle sections. Think about what this means for how you use AI. If you're giving the AI a long document and the critical information is buried in paragraph 15 of 30, the AI is statistically more likely to miss it or get it wrong. Not because the model is bad, because of how attention mathematically works at scale. So we have two problems now. Information gets pushed out when the context is too long, and information gets ignored even when it's still technically visible. But wait, aren't newer models supposed to have massive context windows? Yes, and that creates its own set of problems. Context window sizes have exploded in recent years. Local models often have limits around 2,000 to 4,000 tokens. But cloud models now offer 128,000, 200,000, even up to 1 million or 10 million tokens in some experimental models. That sounds like the problem is solved, right? Not exactly. Here's what happens when you expand the context window. First, VRAM and compute requirements skyrocket. The model needs exponentially more memory to process longer contexts. Second, response times slow down significantly. More tokens means more calculations, which means longer waits. Third, and this is the one no one talks about, hallucinations increase. When the model has to maintain attention across millions of tokens, the probability of errors and made-up information goes up. There's also a security dimension. Longer context windows mean more space for hidden instructions. Attackers can embed malicious prompts deep in a large document, hoping the AI will follow those instructions without the user noticing. The bigger the window, the bigger the attack surface. So more context isn't automatically better. It's a trade-off between capability, speed, accuracy, and security. Alright, so now you understand the limitations. Let's talk about what you can actually do about them. There are two categories of solutions here: how you use AI models in your daily workflow, and how you optimize models if you're running them locally. Let's start with the workflow fixes. First, start new conversations when you change topics significantly. If you've been discussing marketing strategy and now you want to debug code, don't continue the same thread. Start fresh. You'll get faster, more accurate responses because the model isn't wasting context space on irrelevant information. Second, when summarizing web pages or long documents, convert them to clean Markdown first. There are tools that strip out all the messy HTML ads and formatting garbage. Clean text uses fewer tokens and is easier for the model to parse accurately. Third, front-load and back-load your most important information. Remember the U-curve. Put critical context at the beginning of your prompt. Put your specific question or instruction at the end. Don't bury the important stuff in the middle. Now, if you're running models locally, there are technical optimizations that can help. Flash attention reduces memory usage and speeds up the attention calculation. KV cache quantization compresses the model's internal memory, allowing larger context windows on the same GPU. Paged cache manages memory more efficiently by only loading what's needed. These techniques let you squeeze more context out of limited hardware. The point isn't to fight against the context window, it's to work with it. Understand its limits, structure your inputs accordingly, and you'll get dramatically better results without needing to wait for some future model that fixes everything. The constraints exist for mathematical and physical reasons. Smart usage beats brute force every time. Let's bring this together. The context window is the AI's short-term memory, and everything, your messages, responses, files, system prompts, competes for the same limited space. Tokens are the unit of measurement, and you're probably using more than you think. The lost in the middle phenomenon means information at the center of long contexts is more likely to be missed or misunderstood. Bigger context windows help but come with trade-offs: slower speed, higher costs, more hallucinations, and larger security risks. And practical fixes like starting fresh conversations, cleaning your inputs, and strategic information placement can dramatically improve your results right now. At the start of this video, you probably thought the AI was just randomly forgetting things. Now you understand the exact mechanism behind it. And more importantly, you know how to structure your interactions to minimize the problem. The best AI users aren't the ones with access to the biggest models. They're the ones who understand how these systems actually work. That understanding is now yours. If this changed how you'll use AI going forward, like this video, it tells the algorithm that technical depth is what people actually want. Subscribe if you want to keep understanding the why behind the tools everyone else just uses blindly.